In standard Layer 1 architectures, raw computational throughput and strict gas limits severely limit high-frequency on-chain algorithmic trading. Because strict gas constraints dictate execution complexity, current Web3 prediction markets are restricted to processing static, low-computation state changes. The Somnia Layer 1 bypasses these constraints by operating at over 100,000 transactions per second with sub-second finality. To capitalize on that bandwidth, we designed the Quantitative Decision System, or QDS. It is a trading terminal built specifically for this high-throughput environment. QDS integrates three distinct primitives directly on-chain: multi-model AI agents, deterministic bonding curves, and post-quantum cryptography. Extreme throughput serves as the computational bedrock required to execute these disparate mathematical operations simultaneously. This diagram illustrates the foundational smart contract layer. Notice the primary logic block, the QDS event market router, locking into the center of the grid. This router directly manages all discrete binary event contracts on the platform. Expanding this block reveals the core invariant floating above it. Yes shares plus no shares exactly equal 1 USD. Watch how the market maker pools fluctuate inversely, permanently maintaining the exact $1 settlement peg. As incoming capital flows into the contract, it forces an alteration in the ratio of yes and no shares, which dynamically updates the probability odds quoted to traders. Rigidly enforcing this strict mathematical invariant guarantees zero-sum settlement and secures the decentralized liquidity pools against any risk of insolvency. Above this on-chain router sits the off-chain intelligence layer driving automated execution. This pipeline visualization shows live market data flowing upward from the Layer 1 grid into a dual-node interface running both Gemini 3.7 flash thinking and Gemini 3.1 Pro models. These agents generate a continuous reasoning trace by parsing candlestick patterns for a trading strategy. Once decided, the LLM compiles a payload that travels back down the pipeline, striking the router block below. This direct pipeline allows for instant on-chain execution based entirely on automated agentic analysis. Bridging transparent off-chain language model logic with a rigid on-chain AMM transforms a static prediction market into a highly responsive quantitative terminal. Beyond trading existing events, the protocol relies on a specific mechanism for issuing new community prediction tokens. This graph maps the logic of the QDS bonding curve token contract, which functions as a fair launch initialization tool. The formula deterministically scales the token price based on the total supply squared. Notice the dashed threshold line. Hitting this strict 69,000 USD SO ceiling triggers the liquidity assets to bundle together and route towards the Somnia DEX. Hitting that upper threshold triggers an immediate, uncensorable migration of liquidity directly to the primary exchange. Replacing human operators with a deterministic quadratic formula acts as a continuous algorithmic audit, removing standard trust assumptions from the launch process. To manage the resulting market activity, the architecture includes two experimental smart contracts designed for complex system telemetry and long-term security. First is the QDS Conway Registry, an on-chain tick recorder. This simulation uses Conway's game-of-life cellular automaton rules. The dense, evolving clusters of active cells you see here map directly to highly concentrated trading swarms. By mapping market volatility to the automaton's rules of birth and overpopulation, engineers can observe how individual trades cluster into self-sustaining liquidity swarms or dissolve into market entropy. Beneath this telemetry sits the terminal's persistent security layer, the QDS Quantum Vault. Securing the terminal's long-term state requires moving beyond standard ECDSA signatures. This geometric structure represents the Crystal's Kyber 1024 algorithm. It implements NIST-compliant 256-bit quantum-resistant key pairs. The vault operates by anchoring these complex post-quantum lattice proofs directly onto the Ethereum virtual machine. While cellular automata model the reflexive patterns of market dynamics, the Kyber 1024 lattice proofs guarantee the terminal's structural integrity against future computational threats. This macro diagram displays the fully populated architecture stack. You can see the AI API nodes, router block, bonding curve graph, Conway grid, and quantum vault lattice all running concurrently. A transaction begins when the LLM agent generates a trade signal. Notice the glowing pulse routing from a Web3 wallet directly into the Somnia Testnet, checking AMM odds at the router, verifying lattice signatures at the vault, and updating cell states at the registry in a fluid loop. Executing this continuous multi-contract loop relies exclusively on Somnia L1's massive gas limits to process without stalling. Despite the complexity under the hood, the system remains accessible to developers, utilizing direct test token claims via a centralized faucet hub. By fusing high-speed automated liquidity, multi-model AI logic, and post-quantum cryptography into one deterministic environment, QDS delivers a highly capable execution terminal. This macro diagram displays the fully populated architecture stack. You can see the AI API nodes, router block, bonding curve graph, Conway grid, and quantum vault lattice all running concurrently. A transaction begins the moment the Gemini LLM agent generates a visual trade signal. Notice the glowing data pulse. It routes seamlessly from a Web3 wallet directly into the Somnia testnet, checking AMM odds at the router, verifying lattice signatures at the vault, and updating cell states at the registry in a single fluid loop. Executing this continuous multi-contract loop relies exclusively on the Somnia Layer 1's massive gas limits to process without stalling. Despite the complexity under the hood, the system remains accessible to developers, utilizing direct test token claims via a centralized faucet hub. By fusing high-speed automated liquidity, multi-model AI logic, and post-quantum cryptography into one deterministic environment, QDS delivers a highly capable execution terminal.